Okay, welcome ladies and gentlemen. I'd like to thank you for coming back to Math with Kieno. Today we're going to do the second part, which is solving systems of equations using substitution and elimination. Okay, now just to fall back, we remember the graph method, which is the first way that we explain or demonstrated how to solve a system of equation. Alright, we got two lines. We want to figure out where they intersect at, if they intersect at all, or if they're the same line. So there's three conditions when we solve for systems of equations. So we have this line plotted out, this line plotted out. We see where it intersects here at, from the origin, 1, 1, x value 1, y value negative 1, 1, negative 1. And so this is the solution, 1, negative 1. Here is another one we did on a previous video. Okay, we have a line here and a line here, and they intersect here. We plotted our lines out, and we found out where the lines intersect. And it is at 2, negative 2 from the origin, 1, 2, down 2. So 2, negative 2 is the solution for that. Then another situation that we could have are parallel lines. And we will know this because the slopes will be the same. This y equals mx plus b is the slope form. This is in y equals m slope x plus b, y-intercept. Okay, if you watched the previous video, you understand how that works out. If not, I encourage you to go to the first systems of equations video. Okay, so we knew that the slopes were the same, and they had this intersected the y-axis at positive 4, 0, 1, 2, 3, 4. And this equation, linear equation, intersect the y-axis at negative 6, 1, 2, 3, 4, 5, 6. Okay, so that was the first way. Just a little quick overview on that. So now, substitution and elimination. I kind of use them where they work out for me the best. Substitution is, and sometimes you can do them both. So that's why I just kind of work these out, and I just kind of look at the question, see what's good for me, how I want to work it out, and then just plan it out and execute. So here we go. Let's say our equation is, equation A is negative, I'm sorry, not a negative. It is 3y plus 2x equals 11. Now a little bit. And the second one is y plus 2x equals 9. Alright. On this one, I want to use elimination. Okay, so what I will do is I will take the top equation, because you got to kind of see, okay, does anything match? Anything balance? Yeah, the 2 and the 2 match. Okay, so now I want to use elimination, which is, it's kind of like, it's kind of when we isolate a variable when we are substituting. So they kind of go hand in hand to me a little bit, but as long as you come up with the right answer, that is the main thing. All right, so my substitution and elimination kind of go hand in hand, but what I would do is I would multiply this by negative 1, the top equation, and I got multiply, in parentheses I'll put negative 1. All right, so this would change the top equation to negative 3y minus 2x equals negative 11. Okay, and we can do that. All right, so then what we do is we look at this, and we see that the 2x cancel out. We wind up with negative 2y equals negative 9, negative 2. 9 Negative 11 is 2, so y is equal to 1. Okay, so off to the side we have our x. You see, that's what it's all about. If we come back here, we bring the camera in, we want to find the coordinates. This is 4, 1, where these two intersect at 1, 2, 3, 4, 1. So we have our x coordinate, which is 1. Or, I'm sorry, y coordinate. Because we just solved for y. My bad, my bad. Okay, so now what we could do is take the equation that's not beat up so bad. I try to go with the easiest one. Right? So this is y is 1. We found out that y is 1. So I would say 1 plus 2x equals 9. Right? Subtract 1 from both sides. 2x equals 8. Minus 1, these cancel out, minus 1, 9 minus 1 is 8. And divide both sides by 2, x is equal to 4. 4, 1 is the place where these two lines intersect. Okay, and if you wanted to test it out, we could put 1 here, 4 here, 1 here, 4 here. And they both are gonna, alright, let's just say 3 times 1 plus 2 times 4 equals 11. I can see it already. 3 plus 8 equals 11. That checks out. Alright, and then we come back and we say 1 plus 2 times 4 equals 9. This is 8. 1 plus 8 equals 9. So our x and y value works in both equations. And so we have the answer and we solved it. So this is the substitution method, because we isolate a variable, then we substitute by plugging it in to the equations. So that's why. And on our next question, 4x plus 3y equals 1 and 3x plus 5y equals negative 13. Alright. Now, I really don't see anything that'll balance out with each other. So what I can do is I can multiply the top by negative 3 and the bottom by 4. Because I want to get a negative, positive 12 to eliminate each other. So 3 times, now we never ever lose sight of this major equation because we're just reworking it to fit our situation. So this is not the easiest thing to do, and you have to keep in mind. So we got negative 12x minus 9y equals negative 3. And on the bottom, we have positive 12x plus 20y, and we're going to have negative 52. All right, so we're going to work with these. Negative 12x and 12x is 0x. Negative 9 and 20 is 11y. Alright, and then 3, we're adding down, and 52 just winds up negative 55. So y is equal to negative 5. We have negative 5 as our y variable, and or y value. And then what we need to do is we could take either one of the equations, insert negative 5 in y, in place of y. This is x plus 3 negative 5 equals 1. 4x minus 15 equals 1. 4x, add 15 to both sides, and it equals 16, and then x is equal to 4. 4 is our value. So now, in order to test, to really make sure we know what we're doing, x goes into 4 goes into x, negative 5 goes into y. So 4 times 4 plus 3 negative 5. We want to see if that equals 1. 4 times 4 is 16, plus negative 5 and 3 is negative 15. That will leave us with a positive 1. That checks out. Three x for the 4 value, or 4 for the x value, and 5, negative 5, equals negative 13. 12 plus negative 25 equals negative 13. For the 12 there, 1 and 3 come down, negative. That's the bigger number. This one checks out too. So you can see how that works out. Even though we started with this, we could do some things to manipulate, if need be, to come to our end. All right. Okay, let's find something good on our last question. We'll do a relatively easy one. 7x plus 2y equals 2. X minus 2y equals 14. Nose itching. Okay, so this is pretty much done for us. We know that this is going to cancel if we add down. This is going to be 8x. This is going to cancel out 0y. And this is going to be 16. We'll work this out. This is going to wind up being 2. If we divide both sides by 8. So our x value is going to be 2. I keep doing that. I think I'm getting tired. Okay, so now that we know our x value, then what our job is to do is to plug in 2 into the x value, and now we're going to find y. So 2 minus 2y equals 14. Negative 2y, we're going to subtract 2 from both sides, and this is going to wind up being 12. Y is going to wind up being negative 6. Now again, we need to test. So we come back, and 2 is x, y is negative 6, and it has equal 12. Again, 2 is x, y is negative 6. We substitute, so 7 times x is 14 plus 2, negative 6, negative 12. 14 and negative 12 equals 2. That checks out. X in the second equation, 2 minus 2 times negative 6 equals 14. Well, if we take 6 and negative 2, that is going to be positive 12. And if we add 2, that's going to be 14 equals 14, and the second one checks out as well. So just start out working them like that. That was probably one of the easier ones. Okay, if you have any more questions, just ask. I can do more videos if that's what you need, or give you some explanations. The next one I'm going to work on, because there is actually such a thing as a system, solving for a system of equation with 3 linear equations, where you would have, I mean, I'm not saying that this is equivalent, but you would have you'd have 7x plus 2y plus 3z equals 15, and then you know, 8x minus 2y plus 3z equals 11, and then boom. So you could have 3 systems of equations and stuff. So they can do some really, really weird stuff. It's kind of cool. But if it comes to that, we'll work it out. Thank you for watching Math with Kieno. Have a great evening.